Okay guys, we are from micromilling group. We will present about micromilling. This is our member. This is a point that we will present in this presentation. First, introduction. In introduction, milling is a subtractive manufacturing process that uses rotating cutting tools to remove material from starting stock piece, commonly referred to as the workpiece. And then, the micromilling. Micromilling is a fabrication method that creates microscale feature via cutting tools that remove bulk material. The difference from milling and the micromilling is the accurate and details for forming the workpiece. And micromilling is one of the emerging fabrication technologies. It's characterized by mechanical interaction of a sharp tool with the workpiece material causing leakage inside the material along defined part and eventually leading to removal of the useless part of the workpiece in the form of chip. Next part is history line. In the late 17th century, clockmakers, builder of scientific instruments and furniture, and gun makers began to switch to machine capable of making steel. And next, in 1800, by Henry Maudslay, the first practical metalworking lathe was invented. And next, in 1818, American Eli Whitney built a pioneering horizontal milling machine. And in 1861, Joseph R. Brown invented the universal milling machine. And in 1983, Norio Taniguchi from Tokyo Science University defined the concept of nanotechnology to refer to production technology to get the extra high accuracy and ultra fine dimension. Next part is system overview of the machine. Next, first, overview of all component micromilling machine. We can see in the picture A that micromilling has some components. First, there is machine or CNC to set up the design and set up machine. And second, in the micromilling, there's spindle, a cutting tool, usually use end mill or fast mill, and the last is the work table. Next slide, we can see overview of real micromilling machine in the picture of B. And we can see overview of specimen result from micromilling in the picture C.
So I'm Sandia Sanigat. I will explain about the material can be used for milling. So there is 4 material can be used for micromilling. The first one is metals, the second one is plastic, the third one is glass, and last is wood. And after that, I will explain the advantage of the micromilling. The first one is this micromilling technology include the applicability of a broad range of material, including hardened tools, still the capability of manufacturing 3-dimensional geometries, accurate machining of complex features, and it's economical for small and medium lot size, etc. The micromilling also using specialized technique and tool is that it allows the repeatable as efficient production of small and intricate parts that have tight tolerance. So this micromilling have a good advantage for the small and medium size of the material that need higher precision and detail. The disadvantage of this micromilling is cannot process big size material become a final milling product because this is just focus on small and medium size of material. The second one is need some material special maintenance to manage the machine in good performance. This is because the process is more complex than the common milling process. So the second and third disadvantage is relatable. And the function of this micromilling is able to create any product which has very small size with high detail and high precision. So this is relatable with the advantage, which the function is this is the advantage. The second one is to include multitasking capabilities for the machining center to completely machine workpiece in a single handling. So because the high precision and high detail, the process can become in the single handling, even though there is a more complex process in that process. And the last function is make the milling process of small material become effective and efficient, because this is micromilling. This is good for the small and medium material in the economical and the process.
Then the next slide is process. The first process is geometry design. For example, like linear and rectangular microchannels. The design of experiment and craft by plotting appropriate software package available in-house for the various combination of workpiece material, cutting type, size, and geometric features. And then the next process is material selection and preparation, for example like aluminum and steel. Next is cutting parameter, and after that prototyping, for example like CNC programming, machine setup, prototype manufacturing. Then the last process is measuring, for example like preparation of the sample, machine setup, and measurement. For the micro milling setup, there are feed rate, cutting speed, type of tool, and the depth of cut. And then the depth of cut, spindle speed, and the feed rate should be chosen depending on the workpiece material, cutting tool, and geometry. The machining strategy, for example like step over movement, avoiding sharp changes in cutting direction, use of cutting fluid should be selected by taking into account the specific geometry of the component. Then the next slide is application, for example like biomedical, micro tools for surgery, molds for medical components, and lab on chip. And the second application is watchmaker and jewelry. This is the picture of engraving watch piece plate. And then third is information technology. For example like test membrane for PC, chip manufacturing. Then for the automotive, there are injection nozzles, electrodes for cutting insert, and etc. And then aerospace, for example like mold for miniature planetary gear, wheels attached to a turbine. Then go to the conclusions. So micromilling is one of the technologies that is currently widely used for the production of micro components and tooling inserts. Depending on part geometry, micromilling might require special machining strategies that go beyond simply scaling everything down. Real-time feedback of measurement made by different sensors allows machine tools to monitor and take corrective actions, which is in turn increase precision and help select appropriate machining parameters. With an increase in real-time feedback reliability, better process parameters can be obtained and a higher part precision can be achieved. I think that's all from our presentations. Thank you.